All right, let's talk about a part of your body you probably, well, never really think about: the fibula. It's that long, thin bone in your lower leg, just hanging out next to your main shin bone, the tibia. And as it turns out, this quiet little bone has a seriously fascinating story to tell.
And hey, it's not just me saying this. This is straight from clinical research. Even when scientists are doing these complex biomechanical analyses, the fibula often gets pushed to the side, treated more like an afterthought than a key player in how we move.
I mean, it's a fair question, right? Surgeons can and do take pieces of the fibula to use for bone grafts somewhere else in the body. So, if we could just take bits of it, does that mean it's just some kind of evolutionary leftover, a spare part we don't actually need? Well, that's the big idea we're going to dig into today.
Because here's the thing. The idea that the fibula is just a static, useless piece of bone, it's completely wrong. Far from it. Your fibula is in constant motion. It's actually performing this incredibly complex, dynamic dance with every single step you take. So, what makes this dance possible? It's this structure right here, the ankle syndesmosis. Think of it as this tough, fibrous network of ligaments that lashes the fibula to the tibia. But here's the key. It's not a rigid welt. It's a super strong, yet flexible connection that provides stability while allowing for all these subtle but absolutely crucial movements.
And right off the bat, here is a huge myth buster. How much of your body weight do you think your fibula is supporting when you're just standing there? It's definitely not zero. In fact, it bears anywhere from 6 to 17% of the load that goes through your ankle. For a supposed spare part, that's a whole lot of work.
And the way it manages that weight is just incredible. It doesn't just sit there and take it. The fibula moves in all three dimensions. It can shift side to side, slide forwards and backwards, and it even rotates. This complex motion, in 6 degrees of freedom, lets it act like this sophisticated stabilizer and shock absorber, fine-tuning your ankle mechanics with every single move you make. Okay, so we've established that the human fibula is, a dynamic powerhouse. But what about the rest of the animal kingdom? Well, it turns out that when you look across all mammals, evolution basically took the fibula down two very different roads. And this shows that great divide perfectly. Across the board, mammals either have a mobile fibula, like ours, or an immobile one that's often fused right to the tibia. The mobile type, our type, is actually less common. You mostly see it in primates and some carnivores. The immobile version, that's the go-to design for animals that are specialists in jumping, burrowing, or even swimming. And this really gets to the heart of it all. Form follows function. Animals like us and apes and bears, we have these mobile fibula because we need to deal with uneven ground. Our ankles have to be able to tilt in and out, that's called inversion and eversion, to keep us stable. But then you have an animal like a jerboa or a mole. They need rigid stability for their very specific jobs, a single powerful lever for an explosive jump or for digging. So let's flip through a little evolutionary family album just to see this principle in action. The variety is just amazing, and every single design is a perfect solution to a very different problem. Here are two fantastic examples of that mobile fibula. For an orangutan living in the trees, that mobility is absolutely essential for gripping branches with its feet. And for the Himalayan bear, which walks on the soles of its feet, what we call a plantigrade gait, that same mobility is critical for staying stable on a bumpy forest floor. Two totally different lifestyles, but the exact same mechanical solution. Now, let's jump to the complete opposite end of the spectrum, the African jerboa. Look at this. The tibia and fibula are totally fused into one super strong bone called the tibiofibular. What does this do? It creates a rigid, unbending lever. It's basically the perfect biological pogo stick for generating massive jumping power. And then you have the cheetah, an absolute masterpiece of evolution. Its fibula is kind of paradoxical. It's fused to the tibia in the middle to give it stability, but the joints at the top and bottom near the knee and ankle are still mobile. This incredible hybrid design gives it both the raw power it needs for sprinting and the subtle flexibility it needs to steer. It's one of the key anatomical secrets to its mind-blowing speed.
This table really pulls it all together. Our mobile fibula is perfect for our two-legged, flat-footed walk. Now look at a cursorial animal, one built for running, like a dog. It runs on its toes, which is called digitigrade, and while its fibula is mobile, the whole leg is built for speed. Then you have the horse, another running specialist, walking on its hooves, unguligrade. It's taken things to the extreme, a tiny fused fibula for maximum stiffness. You see the pattern, right? The more specialized you are for running, the less mobile your fibula gets. How an animal moves totally dictates its anatomy.
So, after that little tour through the animal kingdom, let's bring it back home. Why does this small, overlooked bone in our own leg really truly matter?
When you boil it all down, it's really this simple. The fibula is not a useless leftover. It's a perfect, elegant example of evolutionary adaptation. In every single species, its shape, its size, its mobility, it's all precisely tailored to what that animal needs to do to survive.
This quote from the research just sums it up beautifully. What it's saying is that different animals ended up with similar fibula designs, not because they were close relatives on the family tree, but because they face similar physical challenges. A jumping jerboa and a jumping hare evolved similar legs because the laws of physics demanded it. It's a powerful reminder that function drives form.
And that really leaves us with one last thing to think about. The story of the fibula proves that even the parts of our bodies we totally ignore can hold these profound secrets about where we came from. It really makes you wonder, doesn't it? What other unimportant parts are just sitting there, waiting to tell us their story?